Hello everyone, welcome back to another exciting chemistry video lessons. Now in today's video, we're going to be talking about some likely questions that you can see in your AP exam, IB exam, IGCSE exam, Post-UTME exam, right? And any international standard exam for chemistry. So I'm going to be using my phone to read out the questions while I give you the answers and also explain to you where need be. Is that all right? Now we're going to be going deeper to some aspects uh, this this particular time. So uh, my name is Adrenaline the Bazooka Prophet, and I'm your educator and your coach in chemistry. So I'll be taking you deeper to the aspects of chemistry that are relevant for you. So we'll take the first question that I have here. The first question says, which rule about elements, mixture, and compounds is correct? Now, if you look at the board, this is metallic, non-metallic, mixture, compound. Of course, option A, they gave you copper, they gave you methane, they gave you brass, they gave you sulfur. First of all, option A cannot be correct. The reason be that sulfur is not a compound but an element. Methane is not a non-metallic substance but a compound. Option B also is not correct because brass is a mixture and not metallic. So option B is wrong. And also copper is not a mixture, right? So option C should be the correct answer. Why? Copper is a metallic element, precisely a transition what element. Sulfur is a non-metallic element. Brass is a mixture. Methane is a compound. Option D is not correct because, of course, I've told you earlier, brass is not a metallic element. Brass is a mixture that consists of copper and zinc, right? It is an alloy, and an alloy is a mixture. So the correct answer here is option C. We'll move to the next question without wasting time. Now, the next question says, follow me, which statement explain why isotopes of the same elements have the same chemical properties? Option A, they said they have the same number of outer shell electrons. Option B, they have the same number of neutrons. No. Option C, they have different number of protons. Option D, they have different mass number. I believe, and I'm so sure, that the correct answer here is option A, which says they have the same number of outer shell electrons. I go ahead again to read the question for you to hear me clearly. Which statement explain why isotopes of the same element have the same chemical property? Of course, when you have the same chemical properties, it simply means that you have same proton number or atomic number, because isotopes can be defined as atoms of the same element having the same number of protons or number of or the same atomic number but different mass number. And take note, it is the number of protons or the number of electrons in a neutral atom that tells you the chemical property of an element, right? While the numbers of neutrons tells us the physical property of an element. Take note, a very good example of isotopes, we have hydrogen. Hydrogen, we have one, the same number of proton, the same chemical property, but differences in their numbers of neutrons, and as such, we have different physical properties. Although not every element in the periodic table exhibit isotopy. Some elements do not exhibit isotopy. in which many or some I cannot say here because there are more questions I should make you know before my time runs out. But if you want to know more or learn more, you can join my online Zoom live classes, right? Education is now more than board and marker. It's now more of online. We use sophisticated computers and tech to make sure our students are well and properly nurtured. That is why we are not just teachers, we are educators. We coach you till you get to the university. Even while you are still there, we will guide you so you become a better person in the society. We have already been maintaining track record, honesty, integrity, compassionate. All these attributes are what we have. It's not about the money right now. It is about credible and intelligent diffusion of informations that are correct, that are apt, and that does make sense. So we continue to the next question that says, which formula is an empirical formula? Which formula is an empirical formula? And they gave options here, which are option A, we have C2H4O. Option B, we have C4H8O2. Option C, we have C3H7COOH. Option D, we have CH3CH2CH2COOH. Now, mere looking at this option here, I think you should make a guess to it. And if you are sure of your answer, drop your correct options in the comment section below. Now I cannot tell you the answer. Don't spy. Don't check any medium or media to see the correct answer. Be sure of yourself. Be sure of yourself. Now, the first question you should ask me is, what is an empirical formula? An empirical formula is the simplest formula, meaning simplest ratio formula. Now, one of the ways I tell my students is that check which of them here, right, occurs in their simplest form, that nothing again can be done, that it cannot be further divided. This one can be further divided, right? You can take this one to their molecular formula, this one to the molecular formula, even this to its molecular formula. But this one cannot be further divided again, right? So the correct option here is option A. I caught you right? Yes, that is how easy it is. When you understand a thing, no matter who will try to sway you away, you remain steadfast, you remain firm at picking your answers. So we move to the next question that we have here on paper. Now, the next question we have here says, trying to pick them. Okay. The next question we have here says, which oxide is classified as an amphoteric oxide? We have option A, we have aluminium oxide, we have calcium oxide, we have copper 2 oxide, we have nitrogen oxide. Of course, the correct answer is aluminium oxide. Oxide is a compound in which oxygen can combine with any other element. It can be a melter, it can be a non-melter, but oxygen is the constant value there. And an oxide can be acidic oxide, neutral oxide, amphoteric oxide, basic oxide. An acidic oxide is an oxide of a non-melter, which when it reacts with water can form their various acids. While for basic oxide, they are oxide of a melter, and when they react with water, they form their bases or alkalis. While a neutral oxide can neither behave as an acid nor a base. While that of amphoteric oxide, they are oxide of a melter, which when they react, they have the property of an acid and also as a base. Am I right? Yes, I am. Right, so the correct answer is aluminium oxide. Apart from aluminium oxide, be one of the examples of amphoteric oxide. We can also have what now? We can also have zinc oxide, lead oxide, tin oxide. These are examples of oxides that are amphoteric in nature. So we continue, right? So now we have another interesting question here, which is the question says, which statement describe transition elements? A, they have high densities and high melting points. B, they have high densities and low melting points. C, they have low densities and high melting points. D, they have low densities and low melting points. The correct answer here is A. Transition elements have high densities and also they have high melting point. That is just the answer. Move to the next question quickly. Which gas is made when powdered zinc is added to dilute hydrochloric acid? We have option A, we have carbon dioxide, we have chlorine, we have hydrogen, we have oxygen. Now you give the reaction here. You have zinc in the presence of dilute HCl. Of course, you'll be having zinc chloride plus what now? H2. Of course, hydrogen gas is liberated. And this is just the part 1 of this video. Watch out for part 2. Do well to like, subscribe, and share. Thank you. God bless you.